Welcome back to Solving Problems Together, and today we're going to dive straight into an open-ended problem based on square numbers. We've been told to sum the squares of 4 consecutive numbers and subtract 5, and then to try and describe what we notice. So to get started, we'll try some numerical verification. We're going to try some numbers and see what happens. Hopefully we do notice something with the numbers, but after that we'll try and generalize algebraically and see exactly what's happening. So, first step of numerical verification, I'll start with the numbers 1, 2, 3, and 4. So the squares of each of these numbers are added together, and we've been asked to subtract 5. That gets us 30 minus 5, which is 25. Well, I instantly recognize that as a square number, and that was the next square number after 4. I've added 1 squared through to 4 squared, and got an answer of 5 squared. So this is just one case. What would happen if I worked with the numbers 2 through to 5? Would I get 6 squared? Let's see. So 2 squared through to 5 squared, and subtract the 5. 4, 9, 16 and 25 added together, that gets 54. 54 subtract 5 is actually 49. That's not the 6 squared I was expecting, but it's 7 squared. Okay, there are quite a few different patterns or rules that could be happening here. Is the next one going to be 9 squared? Is it always going to be an odd number squared? Or is there something slightly different that I can't quite see yet? Let's try some algebraic verification, and this should show us exactly what's happening. So, here are 4 consecutive numbers. If n is my first number, and I've squared it, the next number to square is n plus 1, and the following number is n plus 2, and the one after that is n plus 3. So, from n through to n plus 3, they've been squared, and we've subtracted the 5. So let's just be really careful with the algebra here. As we expand each of these brackets, I've written down 3 terms from every expansion, and then we can tidy that up on the line underneath. So I've got 4n squared plus 12n plus 14, subtract the 5. Each time when we subtracted 5, we got ourselves a square number. So I'm looking at this expression and checking whether or not it's a square number. I can factorize it. The terms inside the bracket when I factorize, I'm expecting it to be 2n plus 3. So 2n plus 3, 2n plus 3. I'm just going to double check that this expands correctly, and it does. It gets me the 4n squared, it gets me the 9, and it gets me 6n twice, which is the 12n. Okay, so I'm happy that I've factorized that correctly, and there's the square number I was looking for. How does this square number relate to the original numbers that we chose? And there it is. I've noticed that this is 2n plus 3. It's the first number that I chose to square, and the last number that I chose to square. It's the sum of the first and the fourth numbers we chose. It's the sum of the first and the fourth consecutive numbers. That's the result that we get. We get the sum of the first and the fourth number squared. So here is the first and the fourth term that we had in our original numerical examples. When the first term was 1, the fourth term was 4, and we saw that we got 5 squared. When the first term was 2, the fourth term was 5, and we saw that we got 7 squared. So I should anticipate that if the first term is 6, and the fourth term is 9, I'll get 15 squared. Okay, so I wasn't expecting that, but very nice to see. Now I know that if I was to choose 4 consecutive numbers from 10 to 14, I squared them, added them together, and subtracted 5, I would expect to get 24 squared. If I chose 4 consecutive numbers from 101 through to 105, I would expect to get 206 squared. So as usual, if you can think of any alternate approaches, any other techniques that could have been used to solve the problem, would love to hear about them in the comments. Also, what were your initial thoughts when this problem was posed? How can we take the problem further? And obviously, if you have a problem of your own that you would like us to try, drop all of that in the comments for us below. We read through them all, and we'll get back to you. Do come back again so we can solve another problem together.